Today's lesson is 6.12 and we are talking about inequalities. Our goal is to find and represent all of the values that make an inequality true. So the inequalities that we're working with today will have variables in them, and we'll need to figure out what that variable could be. Now before we even start, just to review this, an inequality would not have an equal sign. Nope. It would have, we could have less than, greater than, less than, or equal to, greater than, or equal to. So when we're looking at these last two symbols here, that line underneath indicates that whatever that top symbol is, less than or greater than, that it could also be equal to it. So a really quick example I'll show you would be 4 is less than or equal to 4. Now generally when we're writing it, we would just write equal, but because we have this bottom line, that does work for us. Turning to page number 244 right now, we are going to start by looking at the top, number 1, naming two solutions of each inequality. So A through H, they're giving us some inequalities with, we have, the same symbols that we just talked about, and then you need to write down two possible solutions. So really, for some of these problems, we could have a lot of different answers. You just need to pick two examples that would work. So looking at letter A, we have 15 is greater than R. So some examples of that, R could equal 1, R could equal 2, R could equal 3, it could equal 4, 5, it could equal negative numbers. I could go on and on and on. You just need to write down two possible solutions and you're done with that problem. Pretty simple to start with. Let's skip B, skip C, and let's look at letter D. So for D, we had another step. We have subtraction. 15 minus 11 is less than or equal to P. So P, we still have a few possible answers. 15 minus 11 equals 4. And now because it says it's less than or equal to, it could be 4 because that would be equal to with that line again that we discussed. It could be 5, could be 6, so on and so forth. You just need to write down again two possible solutions. So this is what you're going to continue doing. We're going to look at letter G also. We have 6.5 is greater than 3 times D. Now we could get really fancy and get into decimals and fractions, but I already know that 3 times 1 would give me 3, which is less than my original number, 6.5. So I'm going to write down 1. It could be 1. Now 3 times 2 equals 6, and 6.5 is greater than 6, so that would work. It could also be 0. And then again, if you wanted to get a little fancier, you could use fractions or decimals as well. Just glancing at number 2, you're doing essentially the same thing, except now you are thinking of two numbers that are not solutions for each inequality. So we want to think of numbers that would not work. So just looking at letter A for number 2, right, number 2 there, we have 7 plus 3 times Q is greater than 40. So just doing some math here first, we know that 7 plus 3 is 10, so 10 times Q is greater than 40. So if I said 10 times 1 is greater than 40, that would not be true, so 1 would not work. If I said 10 times 2 is greater than 40, that would not work. 3 would not work. So you can kind of see the pattern here. We're just picking what would not work, what our variable would not represent. I really like this part of our lesson. It's something unique that we don't talk too much about, but it's kind of fun to do. So looking at number 3, we are supposed to describe, using words, the solution set of each inequality. So our example is t plus 5 is less than 8. And for that, instead of just saying, well, t could be 1, 2, 3, could be less than that, we just need to write down all numbers are less than 3, which is what they did. So we're going to look at A together, number 3A. And our original inequality is 8 minus y is greater than 3. So we need to write down what y could be. So looking at this, we know we have to keep our difference right here greater than 3. So we could say 5, 8 minus 5, no, because that's going to get us down to 3, so it has to be less than 5. And now I could go through and check, but any number less than 5 would work for us. So we're going to write down all numbers less than 5. And that would be our answer. And you need to try 3B independently. All right, this is the part of the lesson that I was referring to when I said it's kind of fun that we get to do stuff like this. So for number 4, A, B, and C, we're going to be graphing inequalities on our number line here. So we're going to start with 4A. Oops, sorry, 4A up here so we know where we're at. And we have x is less than 5. Now, right now, we have no idea what to do because we have not done this before. I'm going to zoom in just a little bit here. But we know that x could be any number then that's less than 5. Could it be 5? No, it could not, because 5, it does not say that it could be equal to 5. So when my inequality has just this simple less than or greater than sign, that means as I'm graphing it, I'm going to be drawing a circle around that number, 5. I'm going to zoom out a little bit. Now, we're going to be indicating our graphing by drawing a line either way, to the right or to the left. And now, since we know x would have to be less than 5, our line will be drawn to the left. And yours will probably look a little neither than mine. And then since it could be any number, I'm going to keep going all the way to the end and draw an arrow. That's showing that any of those numbers covered by my red line could be x, and then my open circle here at number 5 shows that it cannot be 5. Now we have, for 4b, 6 is greater than b. So if you remember what we said the first time, we said that if we have a greater than or less than symbol, that the number that we know, which is 6, we will be drawing an open circle around that, around the number 6, because it's stopping there, but it can't be that number. Now, we know that 6 is greater than b, which means that b cannot be greater than 6. So our graph this time is actually going to look very similar, and my arrow will be drawn all the way down as far as I can go, and I'll draw that arrow to show that it can continue with any of those numbers that are less than 6. Any of those numbers that I picked and put in my inequality would work. So just so we can see an example now, if we wrote 6 is greater than, let's say, -7, that's true. We could write 6 is greater than 0. That's true. We're just showing that any of those numbers can represent our variable b. We're going to do our final problem like this together today as well. You will be practicing this on IXL. And now we have 1.5 is greater than or equal to h. So this is where we see a change. When we have a greater than or equal to, or less than or equal to, that means it could be this 1.5 number. So as I'm graphing it, I'm going to go do my best to find 1.5 here. I'm not going to have an empty circle. I'm going to be filling in that circle. So that's what that will look like, because it could be that 1.5 number. And then I do the same step that I did before. So it's saying that h could not be greater than 1.5. It'd have to be equal to or less than. So again, my arrow will be drawn this way on my number line. Your assignment today will include Math Journal pages 243, which is talking about some division things with decimals, 244, and then your math box 245. You should have a good chunk of 244 done now. We did a lot of that together. And then for IXL today, like I said, you'll get a chance to graph those inequalities. You have AA1 and AA2.